Okay, folks. A multitude of things. I just wanted to give you a sense of the things that are happening over the last little bit of the semester. First of all, I've given the class an opportunity to earn 20 bonus points, plus I gave you a few homeworks for free and other things. You have an opportunity to earn 5 more bonus points, and that is there is a Science Wednesday, the Science of Ceramics, that will happen this Wednesday night at 6:00 p.m. over in Lewis Science Center 102. You have to go, you have to be attentive, you have to sign in. I will get a copy of those that signed in afterwards. Now, today what I'm going to do is we're going to get into using molarity in conversions. Specifically, we'll do a couple of different types of conversions. This is probably the most challenging aspect of molarity, is all of the different types of conversions, because you've got to really think about what it's asking for. You have a quiz that's due at 11:59 p.m. tonight. It is the last quiz of the semester. You will have a homework over this information that is due on Tuesday, tomorrow night at 11:59 p.m. And also the last of the math, chem, and puzzles is due at 11:59 p.m. Now, if you don't finish watching the video, it doesn't record that you've done it. And so that can be a challenge. On Wednesday, we will finish up our discussion of dealing with conversions and doing some more conversion calculations involving molarity. And then we will, there will be a homework that is due on Sunday. And then that is the last homework of the semester. And then your 4th exam is on Monday of next week. And then on Wednesday of next week, I will give you insight into how to study for my final, which means bring copies of your old exams. It will help. So that's kind of how things are outlined prior to the final exam. Any questions? I've actually already written the final, so I know exactly what to let you know. Okay, I don't think there was anything else. Oh, one other thing, which I have not written up on here. And I feel like it may, for some of you, it may or may not make a difference. It all probably depends on how you do on the last exam of the semester. As of right now, I have calculated your grades from 2 perspectives. Number one, with the drops that I have indicated I would do. 1 exam, some of the homework, some of the ed puzzles, some of the this, that, the other type stuff, the quizzes. I also calculated the grades where I dropped the homework and the quizzes and the math ed puzzles, but I left all 4 exams. And here's the option. If you like your grade with all 4 exams counting, you don't have to take my final. If you don't like your grade with all 4 exams counting, you can take my final, and I will drop your lowest exam grade. Now, what that means is I'm about to release 2 columns on the grade book. I wanted to talk about it first because things get a little crazy once I release it. I'm going to release 2 columns. One that will say with exams drop or with grades drop. The other one will say with all exams counting, something like that. So you can get an idea of where you stand. Yes.
So say we want to keep the 4 exams, but that bonus points we did to go toward the final exam, with those be tacked on to this next exam about to take.
The bonus for, the way I do bonus, the bonus is not tacked on to any exam, it's tacked on to the overall grade.
Okay. I just thought that like food we brought, I thought it said on the paper where it says tech on the final or something.
No, it's tacked on to the overall grade. Yes. I added those, anybody that I got hands from, I went ahead and added those points as they were coming in here. Other questions? So in answer to your question, you get your bonus from where? Okay, so when I get back to my office, I'll be releasing 2 columns, but I wanted to discuss them before I release them. And they still will not be finalized until after Monday. So you gotta keep that in mind. And I'll be grading like a crazy lady on Monday night, trying to get your exams up and running, because one of the few things you are going to have to do, and I will put it in writing as a note that comes out on Blackboard and through email. If you decide you're not taking my final, you gotta let me know, because I don't want to waste paper printing. I don't want to kill any more trees than I have to. Questions? Okay. So now we get to get into the last of the new material. My goal is to work problems of the last of the new material today. And that's practice as a group on Wednesday, like I've been doing, where we take some time, I go over it, and then we take some time and you get to work some problems on your own. I'm hoping that method is helping with all of the mathematics. Okay, so what we're going to be focused on is we're going to focus on conversions using molarity. And if I recall, I did some of this last Monday. It's been a while. I'm going to pick up with one problem in that category, 1 or 2 problems in that particular category, just to get our brains functioning before I throw in the concept of stoichiometry also. Let's see. So let's go with what mass of calcium hydroxide is needed to make, at least I don't think I did this one the other day, 2.0 liters of 2.0 molar calcium hydroxide solution. Looking at what I know, I have 2.0 liters of solution. And I know that that solution is 2.0 molar calcium hydroxide. Anytime you see the capital M for molarity, go ahead and separate it out into its subunits of moles, solute, over liter of solution. And it'll always be over the 1 liter of solution. By separating it out, you will see that the volume, 2.0 liters, has only 1 unit associated with it, whereas the molarity actually has 2 units associated with it. When you can perform a calculation that has only one unit associated with it, or I'm sorry, when you can start a calculation that has only one unit associated with it, that is where you should start. So we're going to start with the 2.0 liter solution, and that is what we are going to convert into grams of calcium hydroxide. Now, starting to break this apart, the first thing I see is volume. Anytime I see volume, it means that I'm going to be using the molarity as a conversion factor. So I want to use the molarity as one of my conversion factors that's going to allow me to go from liters to mole. Another thing that I see is that I have grams. Anytime I have grams, it means a conversion factor is likely the molar mass. And I am saying likely a lot because there are other conversion factors I can use, but more often than not, it comes down to the molar mass. So you're going to need the molar mass of calcium hydroxide. Calcium has a mass of 40.078. The oxygens have a mass of 15.9994, and the hydrogens have a mass of 1.00794. So our calcium hydroxide is 74.093 grams of calcium hydroxide is equal to 1 mole of calcium hydroxide. So now we can perform this calculation starting with the 2.0 liters of solution. Our first conversion factor is going to need liters of solution, and that is your molarity. Because I am needing to get rid of the units of liters of solution, I am going to keep the molarity just as it is written, with 2.0 moles of calcium hydroxide in the numerator and the 1 liter of solution in the denominator. We kept the molarity just as it was so that we could get rid of the liters of solution, leaving us with the moles of calcium hydroxide. Now we can use our molar mass. The mole portion of the molar mass will go into the denominator, with the grams going into the numerator. The mole portion did go into the denominator so that our unit and substance would cancel out, and we are left with our grams of calcium hydroxide. Since we are there, we're going to do our math, and we get 296.37 grams of calcium hydroxide, that if you are focused on significant digits would be 3.0 times 10 to the 2 grams of calcium hydroxide. Questions? Mass is grams. Other questions? Let's look at one more example. Okay, let's look at this one. Calculate the volume in milliliters of a 3.50 molar solution of H2SO4 that is made from or made with 49.0 grams of H2SO4. So looking at this, we've been given 49.0 grams H2SO4. We also were given the molarity of the H2SO4 solution. Anytime I see that molarity, that capital M, I go ahead and break it into its components, which is moles of H2SO4 per 1 liter of solution. It's always over 1 liter when you have a molarity. Breaking it down into its subunits, molarity has 2 units associated with it. When you can, you always begin a calculation with a value that has only 1 unit associated with it. So I am going to want to start with the grams of H2SO4 and convert that into milliliters of the solution. So looking at this, grams of H2SO4. Anytime I have grams, again, that means molar mass. So I have 2 hydrogens at 1.00794. I have 1 sulfur at 32.066. And I have 4 oxygens at 15.9994 each, which means that the molar mass is 98.079 grams H2SO4 is equal to 1 mole of H2SO4. The next thing I see is I see volume. When you see volume, it means, at least for the most part, we're going to use the molarity as our conversion factor. But folks, to be able to use the molarity as the conversion factor, we need our volume in liters. And what we want is milliliters. So we're going to have to use one additional conversion factor here. We're going to have to use our metric prefix conversion factor. in order to convert 1,000, and that's 1,000 milliliters is equal to 1 liter. So now we begin with our 49.0 grams of H2SO4. We're going to start with the molar mass as our conversion factor because we've got to get rid of our grams. The mass portion will go into the denominator with the mole portion in the numerator. We place the mass portion in the denominator so that the unit and the substance cancel, and we're left with moles of H2SO4. Now we can use our molarity, but we currently have moles of H2SO4 in the numerator. We need to get rid of moles of H2SO4, which means we're going to have to flip the molarity over so that the mole portion of the molarity goes into the denominator. With the liter portion in the numerator. You always have to keep in mind what you want, and we want in milliliters. So then we've also got to turn that liters of solution into milliliters of solution using the metric prefix conversion factor. Again, we put the conversion factors in the order we did so that our units and our substances canceled along the way. And when we get to this, you get 142.7 milliliters of our H2SO4 solution, which we would, if you're keeping up with sig figs, would be 143 milliliters of solution. Questions? Yes. Okay, so the question is, do you take into account your conversion factors in significant digits? And if I look at this and focus on the significant digits, my original value had 3 sig figs. The mole portion of a molar mass is an exact quantity, so unlimited. The or infinite. The mass portion had 5 significant digits. The liter portion of molarity is also an exact quantity, so unlimited number, whereas the 3.5 had 3 significant digits. And then your metric prefix is an exact number. So even, so the one with the fewest was 3 sig figs, so your answer should be 3 sig figs. Now to answer your question, most of the time, and I don't want to say always because there's always a chance that that's not the case, but most of the time, the numbers that are given in your original problem will be what determines the significant digits. So if you look at the two numbers in the original problem, they both had 3 significant digits, so the answer had 3. Now, the reason a lot of times we don't take into account the molar mass is because, again, it depends upon exactly which table you're using. And if you use a good table, you get way more significant digits than you do in the original, than you do in the number, than you have with the numbers for the original problem. So normally you can just look at your original problem. Other questions? Okay, so that is some of the That's conversions using molarity. Now what we're going to do is we're going to combine conversions using molarity and stoichiometry. So what volume of 0.82 molar sulfuric acid is required to react with 407.5 grams of calcium hydroxide given H2SO4 plus CaOH2 goes to form H2O plus CaSO4. When I have a reaction, what is the first thing I should do? Balance it. To balance it, it comes out 2 waters. So the next thing I'm going to do is I'm going to get out the information out of the question. I have 407.5 grams of the calcium hydroxide. And I have 0.82 molar sulfuric acid. When I see molarity, again, it's time to bring it down out into its subunits. So that's 0.82 moles of sulfuric acid per 1 liter of solution. By breaking molarity out into its subunits, you see that molarity consists of 2 units. That means it's a great conversion factor. And when I can, I always start a problem with something that has only 1 unit. So I'm going to take that grams of calcium hydroxide and I am going to convert that into volume of the H2SO4. Looking at the information, first thing I notice is I have grams. Grams means I need the molar mass. And I calculated it earlier. That's why I was going to steal it. 74.093. Of calcium hydroxide is in 1 mole of calcium hydroxide. The second thing I notice is that my two substances are different. When you have two different substances, what does that mean? You got to have that mole to mole if you've got two different substances. And where does the mole to mole come from in this case? It's a balanced reaction. According to this balanced reaction, one H2SO4 reacts with one calcium hydroxide. So those things are in a 1-to-1 ratio. The last thing I see is I have volume. Volume means I'm going to use my molarity. So, having pieced out the possible conversion factors I need, I'm going to go in here and begin with the 407.5 grams. Your first conversion factor must have grams. So we're going to use the molar mass as our conversion factor. Of the molar mass, the gram portion must go into the denominator, while the mole portion goes into the numerator. We place the mass portion in the denominator so that the unit and the substance canceled, leaving you moles of calcium hydroxide. Now that we have it in moles, we can convert into moles of sulfuric acid using the fact that for every mole of calcium hydroxide that reacts, 1 mole of sulfuric acid is required. From that mole to mole ratio, the mole of calcium hydroxide was placed in the denominator so that the unit and the substance would cancel, leaving you moles of sulfuric acid. Now I've got to get rid of moles of sulfuric acid. It's currently in the numerator. To do so, you're going to have to flip the molarity. The 0.82 moles of sulfuric acid will need to go into the denominator with the 1 liter of solution in the numerator. The mole was placed in the denominator so that the unit and the substance canceled, and you were left with liters of solution. When you key this into the calculator, you will get 6.7 liters of solution. Questions? Let's look at another example. What volume of 3.0 molar hydrochloric acid is needed to completely react with 1.2 liters of a 1.7 molar calcium carbonate solution given calcium carbonate reacts with hydrochloric acid to make carbon dioxide plus calcium chloride plus water. Okay. So listing out what we have 3.0 molar HCl. We have 1.2 liters of calcium carbonate solution. And we have 1.7 molar calcium carbonate. Now, when there's a reaction involved, what should I do? Balance it. So I need 2 hydrochloric acids. Okay, if we take our molarities and we actually break them down into their meaning. You will see that there is only one value that has a single unit associated with it. And that was the volume of the calcium carbonate. So it is that volume of calcium carbonate that we want to turn into volume of HCl. I see volume, calcium carbonate. It means that you need the molarity of calcium carbonate. I see that I have 2 unique substances. I have calcium carbonate and I have HCl. Anytime you have 2 unique substances, you need your mole to mole ratio, which in this case was 1 mole calcium carbonate to 2 moles hydrochloric acid. And then I see that I have volume that I'm wanting. And again, if I see volume, I automatically think molarity. So let's begin this calculation with what we were given, which was the 1.2 liters of calcium carbonate. My first conversion factor is going to contain the liters of calcium carbonate solution. So that means I'm going to be using its molarity. Of that molarity, the liter portion has got to go into the denominator. So that the units will cancel. You now have moles of calcium carbonate. Now you can use the mole to mole ratio. 2 moles of HCl go in the numerator with the 1 mole of calcium carbonate in the denominator. The 1 mole of calcium carbonate was placed in the denominator so that the unit and substance canceled, and you were left with moles of hydrochloric acid. Keeping in mind what you wanted volume of hydrochloric acid. But I currently have moles of hydrochloric acid. I have got to use my other conversion factor, but I'm going to have to flip this conversion factor because I need the moles to be in the denominator. You had to flip it so that the unit and the substance canceled. So we have 1.2 times 1.7 times 2 divided by 3, and that gives us an answer of 1.4 liters of solution. Specifically, it's 1.4 liters of HCl solution. Questions? Okay, let's look at another example. By the way, you'll notice that pretty much all the molarity problems I've done today, none of them are identical. It's the process that's identical. I identify where to start the problem. I then piece out the unit, piece out the information of where I'm starting, where I want to go to identify possible conversion factors. The process is the same. So let's look at another problem. .0 milliliters of HCl is titrated against 30.0 milliliters of .75 molar barium hydroxide. What is the concentration of the hydrochloric acid? Okay, let's look at what we have. We have 50.0 milliliters of HCl that is titrated with 30.0 milliliters of BaOH2. That is a 2.75 molar BaOH2 solution. And the reaction, which I forgot to write, is HCl plus BaOH2 goes to form 2 waters plus BaCl2. Folks, I'm going to start the same way in that I'm going to take that molarity and I'm going to divide it out into its subunits. So that's going to be 2.75 moles of barium hydroxide over 1 liter of solution. But here's where this particular type of problem is a little bit more tricky. I have 50 milliliters of HCl that has only 1 unit. I have 30.0 milliliters of barium hydroxide, which has only 1 unit. Which of those 2 pieces of information do I start with? And here's how you answer that. If you look back at every single problem we've ever done, we've never started with the material we had the question about. If you look at every single problem we've ever done, we never started with the material we had the question about. We always started with the other substance. So since our ultimate goal is to determine the molarity of HCl, that is what we want to know. I'm not going to start with the molarity of HCl. I'm not going to start with the HCl, is what I meant to say. Again, we never start with the substance we have a question about. So in this particular case, I will be starting with the barium hydroxide. And we will be converting that barium hydroxide into moles, into the molarity of HCl. Now, some of the questions that we normally ask ourselves are going to be the same. The very first thing I note, I have a volume, and volume means I'm going to be using my molarity as the conversion factor. But to use that molarity as the conversion factor, the units need to be in liters, but right now they're in milliliters. So I'm going to need to take that volume and use the metric prefix system, where 1,000 milliliters is equal to 1 liter, in order to convert that volume into the appropriate unit. I notice that I have 2 different substances. I have barium hydroxide, I have hydrochloric acid. 2 different substances means I'm going to need the mole to mole ratio. Which, according to the balanced chemical equation, 2 moles of HCl reacts with 1 mole of barium hydroxide. It's the next piece that's the challenge, in that I don't want something that has only one unit. I want molarity. And you have to keep in mind what molarity is. Molarity, is equal to moles over liters. So when we're done with this calculation, we should have moles in the numerator. We should have liters in the denominator. Okay, so now to start this problem, I said I'm going to start with that 30 milliliters. So I'm going to take that 30.0 milliliters of barium hydroxide. First thing I'm going to have to do is convert that into liters of barium hydroxide using the metric prefix conversion system, where 1,000 milliliters is 1 liter. The milliliters were placed in the denominator so that the units canceled and you're left with liters. Now you can use the molarity of barium hydroxide, which was 2.75. That's 2.75 moles of barium hydroxide over 1 liter of solution. The liter portion of that concentration had to go in the denominator so that the unit and substance cancel, leaving you moles of barium hydroxide. You then need to convert that moles of barium hydroxide into moles of hydrochloric acid, with the fact that there were, for every 1 mole of barium hydroxide, you used 2 moles of hydrochloric acid. The moles of barium hydroxide were placed in the denominator so that the unit and the substance canceled and you were left with moles of hydrochloric acid. And if you look at the ultimate goal, you have half of the information. For the molarity, you know currently the moles. Which is 0.165 moles of HCl. Now we need to know the liters of solution. Make sure I didn't type it wrong. 30 divided by 1,000 times 2.75 times 2. Yeah, 0.165. So I did 30 divided by 1,000 times the 2.75 times the 2. Yeah, I go straight through. You could do the 30 times the 275 times 2 divided by the 1,000. It's just. Now to get the molarity, you still need the liters of solution, and you were told you had 50 milliliters of hydrochloric acid. You need to take that hydrochloric acid and convert it into liters of hydrochloric acid. 1,000 mils is 1 liter. So that means it's 0.0500 liters of HCl. That goes into the denominator. And that allows you to perform the calculation you needed to perform to get 3.3. 3.30 molar HCl. Questions? Yes. Because when I took the 0.165 that I got from the beginning, and I divided it by the volume in terms of liters, divided by 0.05, that 0.165 divided by 0.05 is 3.3. And I had to add that 0 at the end, because if you look at all the starting values, they all had 3 significant digits. So I made sure it had 3 at the end. Questions? This is the toughest type. It's the toughest type because it's not just a single conversion that you have to do. I mean, you can, but it's for most anytime. So here's what I would suggest. Anytime you're asked for the molarity, figure out how to get the numerator and then figure out how to get the denominator and then combine them. That will be easier than trying to put it all in one conversion. Anytime you're asked for molarity, get the numerator, get the denominator, then combine them. It'll make it much easier on you. And you can always guarantee that the numerator is going to require a lengthy conversion, relatively speaking. Okay, so the plan, and I mean, I've done 5 or 6 problems today. I know it gets tiring hearing the same things over and over and over, but this is something that takes practice over and over and over. I can assure you that this is a challenge, and it's going to continue being a challenge for a lot of people. I've seen it over the years. It's just one of the tougher calculations we do. So we are going to practice all day Wednesday. I am going to bring in a worksheet. Now, before I go into any further specifications on that worksheet, I'm going to give you a choice. That worksheet can be just all molarity problems, all mixed up. So calculation of molarity, calculation using dilution, calculation with a straightforward conversion, calculation with conversion using stoichiometry as well. It for certain will have all of that. The question is, do I also add some mass-to-mass conversions in there as well? Or do you feel confident in those and should just focus on the molarity? Because on your test, I think there's 3 balancing chemical equations questions. I want to say there are 2 molarity conversion problems like I started today with. I want to say there's only 1 molarity problem similar to what I ended today with. Not ended, but the last portion of the day. There's one where you have to calculate the molarity using mass to moles and then volume in liters. And then there's one that you have to do a dilution. There's also a mass-to-mass conversion. And I will say on the test, one of the things that I did is I gave you the molar mass, majority of them, so you're not going to have to calculate the molar mass except once, which is a molar mass question, just like on the last test. If you need the molar mass, I think I gave you all the molar masses, so you're not going to have to spend time doing that too. And unless it's a balancing chemical equation problem, I gave you the balanced chemical equation to start with, so that you have the starting material, the starting information is all correct. So what type of do you want on Wednesday? Everything mixed? The only thing, now on the worksheet, I won't give you the molar masses. You'll have to calculate those. And I won't give you the balancing equations. You'll have to calculate it or work on those because I think that's useful practice, period. But I'll mix it all up for you. And that way you can practice and practice on Wednesday. Last week's material. That's all I can tell you, which was solution. No, last week was the first type of conversions, I want to say. Can't remember. I wrote it 2 weeks ago now, so my brain's not really remembering which week I'm doing what anymore.